All right, key point of lesson 1, chapter 1, definition of function. Let's make a summary here. So what is the definition of a function? Can you tell me? Can you tell me that? All right, so a function in mathematics, a function from a set x to a set y assigns to each element of x exactly one element of y, right? So let's write it here. In mathematics, a function from a set x to a set y assigns to each element of x exactly one element of y. And the set x is called the domain of the function. Okay, so if we illustrate this concept using diagrams, usually we can draw two sets. For example, this set is called x. The second set is called y. And there are three elements in that x. And for example, also three elements in set y. So A corresponds to 1 corresponds to A, 2 corresponds to B, and 3 is mapped to C. This kind of relationship is called a function, right? And of course, there is another type of mapping. We can also have a mapping like this. For example, again, a set x and a set y. So this time we have three elements in x, but only two elements in y. And element 1 in x is mapped to A. Element 2 in x is also mapped to A. And this is also called a function because for any given element in x, there is only one element in y that corresponds to the given element in x. So this is also a function, right? The difference is that in the left diagram, this is a 1-to-1 relationship or 1-to-1 mapping. In the second diagram, this is a relationship which is many to one. But both of them, according to the definition of a function, are functions. Okay, so this is a brief explanation of the definition of a function and the definition of the domain. So what are the range? What is a range? The range or image of a function is the set of the images of all elements in the domain. So for example, in the left diagram, the element A is called the image of 1. And all the images in set Y is called the domain of this function, right? Okay, I'll write it here for you. The range or image of a function is the set of the images of all elements in the domain. Okay, this is a concept of the range or image of a function. Okay. All right, so next, you should be able to tell that we have several ways to express a function. That means we have several types of function notations. So how many types of notations we have learned? Now you should be able to write at least 5 types of notations. Okay, I'll help you to make a summary. Please take the notes by yourself. Okay, first is using a mapping notation. Sorry, mapping diagram. Which we have already illustrated using these diagrams. Okay, so what is a mapping diagram? Mapping diagram has such important elements. First of all, the domain. For example, a set X. Next, a range. For example, set Y. And in X, for example, we have, let's say, Tom, Jerry, Alice, 3 elements. Okay, and for any given element, there is a corresponding element that is a map of the element in X. For example, male, female. Okay, Tom is mapped to male, Jerry is mapped to male, Alice mapped to female. This type of notation is called a mapping diagram, and you can also give the mapping a name. For example, F. Okay, and the second type of notation is called a symbol, fx. So let's write it here. You can also using symbol fx or gx or hx. The letters do not matter. Okay. So in function notation, the symbol fx represents the dependent variable. It indicates that the function f is expressed in terms of the independent variable x. For example, fx equals 3x minus 5. The fx here is called the dependent variable. And the x here is called independent variable. This is also a notation of a function like fx. Any questions? No? All right, the third type of notation is called a mapping notation. So we can also use a mapping notation to express a function relationship. Mapping notation can replace the function notation. For example, this is a function notation, right? Fx equals 3x squared minus 5. If we rewrite this function using mapping notation, we can write it like this. First, write the name of this mapping or name of this function, f, followed by a colon, that's 2 dots, right? And then we say it maps from x to 3x minus 5. That means for any given element x, the image of x is 3x squared minus 5. This is another type of notation of a function fx. So basically, they are the same thing, okay? In some books, you can see a function like this. For example, if you see this notation, you should be able to tell this is actually a function, okay? Okay, let me put a note here. This is called a mapping notation. And the above expression is called a function notation. All right, the fourth type of notation is called a mapping table. So we can also express a function using a mapping table, which looks like this. For example, we can draw a table to illustrate a mapping relationship. Okay. For example, the first column are several names such as Tom, Jerry, Alice, Taylor, and Brian. Okay, several names. And second columns are their genders. For example, Tom is male. That means Tom is mapped to male. Jerry is mapped to male. Alice is mapped to female. Taylor is mapped to female. Brian is mapped to male. Okay. For any given element in the first set, there is only one element in the second set that corresponds to the given element. So this is another type of function, right? It is described using a mapping table. So in essence, this is also a function relationship. Any questions? No? All right. And there is a fifth notation, which is using sets of ordered pairs. Sometimes we can also use a set of ordered pairs to indicate a function. For example, a very large set contains such ordered pairs. Tom, male. Next, Jerry, male. Next, Alice, female. Also, if you check using the functions definition, you can easily see that for any given element in the first set, that is Tom, Jerry, Alice, there is only one element in the second set that corresponds to the given element. So this is a function as well, okay? So according to the 5 different types of function notations, we can see that in essence, function is just a special type of relation or mapping, right? As long as it coincides with the definition of the special relation or mapping. That is, in essence, a function. A function is a mapping. Understand? Okay, let's do a practice to strengthen the concept, okay? Give you a practice. So given a function, such as fx equals x squared plus 1, where x are integers and x is within 1 and 3 inclusive. Your task is to express the same function express a function using different notations below. Okay, first, a mapping notation. Second, a mapping diagram. Third, a mapping table. And last, a set of ordered pairs. Okay, are we clear about the question? I'll give you 4 minutes to think about this, all right? Are you finished? If not, please continue working, okay? All right, you should probably finish. So who can give us its answer? Any volunteers? Any volunteers to give us the answer? No one? Then I'll randomly call one of you, okay? Okay, first row, the gentleman in the red shirt. Hello? Yes, you. Gentleman in the red shirt in first row. Can you give us the solution? So what's your name?
Dennis.
Okay, Dennis, can you give us the solution? Okay, one by one. First, what is a mapping notation? You can speak and I'll help you to write on the whiteboard.
Domain equals x belongs to.
Sorry, excuse me. The question does not ask you to find the domain. Okay, you can continue. Sorry about that. You can continue. Okay, you want to find the domain first? It's okay. Okay, domain is a set.
Domain is X belongs to
This is the domain, right? X is integer and X is between 1 and 3, inclusive. Or simply 1, 2, 3 inclusive. This is the domain. And what is a mapping notation of this function? Remember, in this example here, if you have a function like this, fx equals 3x squared minus 5, then the mapping notation of this function is, first, we specify the name of this function, which is f, right? Followed by a colon. Then we express explicitly the independent variable, then map to the dependent variable, right? Can you follow me? This is the example. Well, Dennis, can you follow me? Yes or no? Yes? Okay, so for this example, the mapping notation should look like this. And back to our question here. If you are given a function like this, what is the mapping notation of this function? That means, can you rewrite this function using the mapping notation? Can you do that?
fx equals
And
equals x squared plus 1.
okay, so this is called function notation, right? And the question asks you to express this function using a mapping notation. So in mapping notation should look like this. First, we specify the name of this function, then followed by a colon, then x is mapped to x squared plus 1. This is called mapping notation. Understand? Can you see the difference? Yes or no? Okay, so the correct answer should be the second one, okay? Because this function is given to you is already in a function notation. All right, next. What is a mapping diagram? We can draw two sets like this, right? First set x, second set y. So in x, how many elements are there? So note here, x are integers and x is between 1 and 3. So there are only 3 elements in the x set, right? And note here, the y, set y should be the image of set x, right? So when x is 1, 1 is mapped to 1 squared plus 1. That's 2, right? When x is 2, That's 2 squared plus 1. So 2 is mapped to 5 in the y, right? And when x is 3, 3 squared plus 1 is 10. So 3 is mapped to 10. So this is called a mapping diagram. And usually we also specify the name of this mapping. That is the name of this function and the middle. Do you understand? Any questions? No? Okay. This is the second type of notation. So how about the third one? Third one is a mapping table, right? If you express that using mapping table, you can use two columns. Goes first column is set x, second column is set y, right? In set x, we have 1, 2, 3, three elements, and each of them is mapped to another element in set y. 1 mapped to 2, 2 mapped to 5, and 3 mapped to 10. So this also expresses the function, but in mapping table, right? Okay, false. You can also express this function using a set of ordered pairs. So first of all, it's a set and a set of ordered pairs. 1 mapped to 2, then 2 mapped to 5, right? According to the table here. And then 3 mapped to 10. And also, this is also the function, but illustrated using a set of ordered pairs. And as you can see here, all of these four types of notations point to the same functions. All right. So in the future, if you see any one of the 5 or 4 notations, you should be able to tell this is actually a function. Do you understand? In essence, a function is a special type of mapping or special type of relationship. Okay, I hope you can understand now. Any questions regarding this example? No? All right, then let's move to the third key point. That is to given a input to a function, find its output, which is very intuitive, right? I'll write it here. Given an input to a function, you should be able to find its output. Or the image. Okay, the method is quite intuitive. We just put it to the function machine. Okay, so sometimes you can imagine the function as a machine. Sometimes you know the internal structure of the machine, and sometimes you do not. But the concept of function is for any given input x, the function will give you an output fx. Okay. Okay, I'll give you a simple example. It won't take much time for this part because the concept here is quite intuitive. So let's see a simple example. Given fx equals square root of x minus 2 plus 3, find f3. Okay, I'll give you 1 minute to think about this question. And as meantime, I'll give you another example. Okay, given another function g. Then find the image of 5. All right, so how about the first one? The solution is, who can tell me the solution? Any volunteers? Just plug that number into the function machine, right? Okay, first row, the gentleman next to the one that answered the previous question. Yes, on your right. Yes, you. What's your name, please? First row. Yes. Yes, you.
Peter.
Hi, Peter. Nice to meet you. How are you today? Good? Good, good. So what is F3 here? Hey, follow me? F3. Is it too easy for you? Just put 3 into the function, right? Square root of 3 minus 2 plus 3, which is 1 plus 3, which is 4, right? So if you want to find the image of 3, just put 3 into that function. That's simple. Okay, Peter, how about the second question? If I want to find the image of element 5, what is the image of element 5 here, G5? Can you tell me that? Okay, so note G is a function, right? And according to the 5 different types of function notation, actually this function is expressed use a set of ordered pairs, right? So each element here in the first position is mapped to another element in the second position. So now I want to find the image of element 5. So where should I look in this function? Where to find the image of 5? Can you tell me that? Can you find that? No? Okay, let me give you a hint. If I rewrite this function using the mapping diagram, x to y, right? So 1 is mapped to 0 in y, and 2 is mapped to e in y, right? 5 is mapped to a element 0. Okay, so also a 0. So let's say you can write it like this. 2 is mapped to e. 5 is mapped to 0. 7 is also mapped to 0, right? So I want to find the image of 5. So where should you look at? Can you find the image of 5 in this diagram or in this set? Can you find that? This checks your understanding of functions definition and functions notation.
There. 0.
0. That's correct. Okay, well done. Because all you need to do is to look at here, right? 5 is apparently mapped to 0. Therefore, G5, which means the image of element 5 is of course 0. Okay, thank you. Okay, any other questions? No? All right, so after that, we'll have a look at how we can determine domain and range for a given function. Okay, so in your notebook, you should write 4. Determining the domain and range. Okay, again, let's go over the concepts of domain and range. So set X here, which is a set of independent variable, is called the domain, right? And for a given function, the range or image of a function is a set of the images of all elements in the domain. That means the second set here, briefly speaking, is the range, right? Okay, so how do we determine domain and range? For the domain, we should consider the restrictions. Okay, what kind of restrictions? The restrictions come from two aspects, right? First of all, it's from the function expression itself. So what does this mean? This means, for example, if you have a ratio A over something, right? Apparently B cannot be 0, right? Because 0 cannot be the denominator. So this is a kind of restriction, right? Other kind of restriction. Okay, let me rewrite this. Other kind of restrictions, such as if I give you a function like this, then in the real number set, apparently under a square root symbol, x cannot be a negative number, right? That's the restrictions from the function expressions itself. And a second aspect is from the real world limitations. Okay, so what does this mean? This means, for example, if your x denotes a length or width or sometimes area, volume, then apparently usually x cannot be less than 0, right? Usually x is larger than 0. Sometimes x can also be 0, right? That's called a limitation from real world. That means if your x has some meaning in the real world, pay attention to the meaning of x. Okay? For example, if x denotes the number of people, then x must be natural numbers, right? Okay, and as to the range, also you should consider all the possible values of the images of the elements in the domain, okay? This is all regarding to the possible images. All right, so I'll give you some example to illustrate this concept. But before that, let's briefly review the commonly used number set, okay? Because in discussing the domain and range, sometimes we're going to be using the different number sets. So I'll give you some commonly used number set, and you tell me what letters should be used to denote these number sets. Okay, so first of all, the natural numbers. And after that, a larger number set is whole numbers. Or sometimes we call them integers. And after that is the rational numbers. Okay, let's say natural number set. Whole number set. And then rational number set. And then real number set. Then the largest set is called complex number set. Okay, so are you familiar with the differences between each types of numbers? Tell me that. Do you know what are natural numbers? What are whole numbers? What are rational numbers? Real numbers or complex numbers? Do you already understand that? Okay, so which capital letter should we use to denote the real number set? Usually we'll use the capital letter N to denote the natural number set, okay? And sometimes if without any context, it's a little bit confusing because the number N can either include or exclude the number 0. You should consult the context to decide if the N includes 0 or not. In this case, we have introduced two other notations, N0 and N1. So the difference is, I'll put it here, okay? The 3 letters means for N, this is a natural number set that can or cannot contain 0. You should consult your context in order to decide whether it contains 0 or not. Okay, in order to clarify, we introduced N0. That's also natural number set. Sorry, missed the number here. That's also a natural number set, but this time we explicitly include 0 or starting from 0, which means it's a set contains 0, 1, 2, 3, etc. Right? And N1 is a natural number set that excluding 0, which means starting from 1. Okay, which means a set of numbers starting from 1, then 2, then 3, etc. Right? Okay, so back to the old days, from the age when I was a middle school student, usually the natural number set does not contain 0. But after that, people try to expand this definition a little bit. So pay attention to the difference here. Okay, because once you study in abroad, sometimes the set n here can also contains 0. And sometimes does not contain 0. Sometimes a little bit confusing. You should consult your context. Okay. And in your own reading, in your own writing, if you do not want to cause any confusion, please use N0 or N1 to explicitly point out whether your natural number set includes 0 or not. Okay. All right, next, a little larger number set is called whole number set. Usually we'll use the letter Z to denote the whole number set. Okay. And rational number set is usually denoted by Q. So what is rational number? Okay, I'll explain this a little bit to you. Real number set is usually denoted by R, and complex number set is usually denoted by C. Okay. All right. So anyone who are not familiar with rational number set or complex number set, please raise up your hands. Okay, I'll repeat. If you are not familiar with the concept of rational numbers or complex numbers, please raise up your hand. No? Okay, let me check your understandings. So second row from left to right, first lady, what's your name? What's your name, please?
Alice.
Alice. How many A's are there? Sorry, a joke. Hi, Alice. So tell me your understanding of rational numbers. What is a rational number? Can you hear me? Okay, whole numbers is like minus 10, minus 9, etc., minus 2, minus 1, 0, 1, 2, 3, etc., right? So what are the rational number sets? Can you explain this a little bit? Rational number set? No? Okay. Can you hear me?
Yes, teacher.
Yeah, so what are real rational number set? Your own understanding does not have to be strict mathematical definitions. Okay, so tell me what's your understanding to real number set? Real numbers. What are real numbers? I'll give you a hint. Real numbers corresponds to any point on the number axis, right? So suppose we have a number axis like this. Any point on the axis corresponds to a real number. Okay. All right. So if you are not familiar with that, my suggestion is to read through this lecture slides. Can you see that clearly? I summarized different types of numbers here. You can check the main number systems from Wikipedia, okay? That will help you understand the basics of numbers. Because sometimes when we discuss any problems, it's very important to set a boundary of our discussion. Okay, so in grade 11 mathematics, if not specified or boundary to discuss any questions, are real numbers. Okay, but besides that, you should be familiar with other concept of numbers. Okay. So basically, back to the question. So for rational numbers, basically any rational numbers can be expressed by a ratio of a over b, where a and b are integers and b is not zero. Okay, such as -3 over 5, -7 over 5, -1, 0, 5, something like that. So the relationships between each type of numbers are also illustrated in the diagram on top left. As you can see here, the complex numbers is the largest number set, which contains real numbers and imaginary numbers, where real numbers contains rational numbers and irrational numbers. Imaginary numbers contains pure imaginary numbers and some other type of imaginary numbers, non-pure imaginary numbers. Okay, and rational numbers contains integers and non-integers, and also integers contains natural numbers and non-natural numbers. Okay, you can take a picture of this. You are encouraged to take a picture of this. This will help you understand different types of numbers and their relationships. Okay. If you cannot see this clearly, please tell your teacher, and you can also ask a copy of my notes. Okay. But you have to let me know. Okay? All right. Because otherwise, I don't know whom should I send this to. Okay. Let me know if you finish. Then we can continue. Are you finished? Yes? Are you finished? All right. Okay, let me know if you need this note or not, okay? Okay, let's see an example to help you understand the definition of domains and range. Okay, let's consider this example. Okay, determines domain and range of each of the following functions. First, function is given in A, and the second function is given in this table. Okay, I'll give you 2 minutes. Probably 1 minute because we're running late, okay? We're running out of time. All right, have you finished? Okay, then I'll give you the solution here, okay? You can check whether it's the same with yours. So for the first, this is a function given by the set of order paired notation, right? So the set of independent variable, which is -3, 5, -2, 5, 6. This is the domain, right? This is a domain. And the range is just the set of all the images, which are 4, which is a set that contains 4, -6, 7, 3, and -8, right? And let's check if this is a function. So for any function, by definition, for any given independent variable, there should be only one image, right? But we can check here. For the element 5, there are 2 images corresponds to 5, right? So apparently this is not a function, right? So this is not a function. Okay, so the relationship shown in this graph in question B. First, let's check the domain. The domain is just a collection of all the inputs here. So that's 4, 5, 6, 7, 9, 8, 10, right? And how about the range? The range is a collection of all the images on the right, which is a set that contains 8, 12, 5, 22, 14, 9, 11. Okay, and I should say, please do not include repeating elements in a set, which means a set does not have does not, let's say a set does not repeat the same element more than once. So if by any chance you have a set like 1, 1, 2, please just write the 1 once, okay? Do not write 1, 1, 2, but write 1, 2. This is a set, okay? And actually this is called a multiset. We'll introduce the definition probably later in this class. Okay, so currently just focus on the concept of a set. This is called a set. If you have a set, you do not have any repeating elements. Okay. All right, so is this relationship a function or not? Let's check if it fulfills the definition. So for any given element in the left column, there is at most one image corresponds to the given element. So this is apparently is a function. Okay. Any questions? No? All right, let's see another example. Determine the domain and range for each of the following functions. Again, I'll give you 2 minutes to think about this question. Remember, when you consider the domain, you should consider the limitations from 2 aspects, right? One is from the expression itself. The second is from the real world problem. Apparently, there is no real world limitations in this question. So that leaves you only considering limitations from the expression itself. All right, let's do this together. The first question, let's consider the domain first. Domain is all possible values of x, right? Are there any limitations for x? Apparently there is no. So the domain is the whole real number set. And again, if not specified in this whole course, For functions 11, please consider your problem, consider question in the real number set, okay? The assumption is we only consider problems in real number set in this course. Okay, and how about the range? When x is any arbitrary real numbers, then 2x is also any real numbers. -5 can also be any real numbers. Therefore, the range is also the whole real number set, right? Any questions? No? Okay, then let's consider question B. So any constraints for x? Answer is no. X can be any real numbers, right? So how about the range? What are the possible values for y? So let's consider the first part. X can be any real numbers. -1 can also be any real numbers. Any real numbers squared can be any real numbers that is not 0, right? So the first part is any real numbers that is greater than or equal to 0, but cannot be negative numbers, right? Then the whole part here, if you have a non-negative numbers plus 3, then you have any number that is greater than or equal to 3, right? Therefore, the range is a set of numbers. Y belongs to the real number set, and y is greater than or equal to 3. Okay? And there is another type of notation for this, which is 3 to positive infinity. 3 is inclusive, right? And first notation is called set notation. And the second notation is called the interval notation. Actually, they are the same thing, but with different types of notations. Okay, you should be careful with this. You can choose either one of them. Okay, so for question C, first let's consider the domain. Any restrictions on x? Of course, yes, because x plus 3 cannot be 0, right? X plus 3 cannot be 0, then x cannot be -3. Therefore, the domain is x belongs to real number set, but x cannot be -3. Okay. Again, this is called the set notation. If you use interval notation, you should write it like this: -infinity to -3 union with -3 to positive infinity. Or you could just say x is less than -3, or x is greater than -3. Or you can also say x belongs to a real number set, but x cannot be -3. You can choose either one, okay? Okay, so how about the range? The range, x plus 3 can be any real number but not 0. Then the reciprocal of this number, of course, is any real number that is not 0, right? Because the numerator here is not 0. So for the range, we can just say y belongs to real number set, but y is not 0. Or in interval notation, you can express it like this: -infinity to 0 union with 0 to positive infinity. Or you can just simply say y is less than 0 or y is greater than 0. You can choose either way. Okay? Any questions? No? All right, let's see last example. This time you're given a real world problem. So you should consider the problem from two aspects. One is from the expression itself, and second is from the real world problem. Amy volunteers to help enclose a rectangular area for a dog run behind the Humane Society. The run is bordered on one side by building the wall. The society has 1 meters of fencing available. Question is, one, A, express the area function in terms of the width. B, determine the domain for the area function. Okay, I'll give a hint. So first of all, it's better to draw a diagram to illustrate this problem, right? First of all, you have a building, and we are building a dog run like this. So this is called the width. Of course, you also have a length, right? And because it's rectangular, the two widths must be of the same length, right? And task is to express the area function in terms of the width. Okay, I'll give you 1 minute to think about these two problems. All right, the two students from the second row on the left, are you finished? Because I can see you doing nothing there. So what is the problem? Do you think it's too easy or too hard? Do not be nervous. It's just a normal question. Do you think it's too easy or too hard? Just let me know so next time I can adjust the contents for you, okay? Can tailor contents for your needs. Have you finished? Hello? Okay, sorry about the delay. We'll finish in 5 minutes, okay? This is our last question of this class. So tomorrow we'll be discussing the linear functions. And the day after tomorrow, we'll be discussing quadratic functions and so on, okay? So for these three functions here, do not panic. You're not familiar with this because we'll discuss we'll discuss them one by one, okay? All right, back to this question. Did you finish? Okay, somebody has already finished, so I'll give you the solutions, okay? You can check whether my solution is similar to yours. So in algebra, usually we'll use letters to denote the real world quantities, right? So here, we want to find the area function in terms of the width. So better to use a letter X to denote the width, right? So let's say let X denote the width as shown in the diagram. So which diagram? Of course, here. This is a diagram. Then we know the length is, okay, so usually we'll give a unit here. The unit is meters. Then the length, also unit is meters, is, okay, so in total we have 100 meters long fence, right? And for the two ways, we have already used 2x. So what's left there, which is 100 minus 2x, is the length, right? So now we know the length and the width. Therefore, we know the area of this rectangular, right? So let's use another letter. Let letter y denote the area of the dog run. So y has unit of square meters, right? Then we know the area y equals the length multiplied by the width, which is 100 minus 2x times x, right? Can you follow me? Okay, so we can discuss from here, which can be simplified to negative 2x squared plus 100x, which is apparently a quadratic function. If you don't know what is a quadratic function, that's okay. We'll discuss this in our following lessons. Okay, so basically this is a function y in terms of x. Okay, next we should discuss the domain of this function. The domain, it comes from the restrictions on x. So are there any restrictions on x? Again, you should consider from two aspects, right? One from the expression itself, which apparently does not specify any restrictions according to the expression itself. Okay. Second, you should consider the constraints from real world limitations. So what are the real world limitations? So note here, x has a meaning, right? The meaning of x is the width. So for width, apparently x cannot be negative number, right? Usually we don't say negative 2 meters, negative 20 meters, right? In this problem, that does not make sense. So here in this problem, x should be a positive number, right? Do you understand? Okay, so that's for the width. Again, do not forget the length is also a distance. The length here can not be negative or zero either, right? The length is just 100 minus 2x. So we have another constraint, which is 100 minus 2x. We use brackets like this to denote we should combine two limitations for our domain, right? So the domain is just the combination of these two limitations. So which is equivalent to, let's simplify this a little bit. First of all, x must be greater than 0. Next, 100 minus x must be also greater than 0, which means 100 must be greater than 2x, which means x must be less than 50, right? So on one hand, x must be greater than 0. On the other hand, x must be less than 50. So if we combine this, final solution is x must be greater than 0 and less than 50. Okay, if you cannot see that directly, you can always draw a number axis to help you analyze. So there are two numbers, 0, 50, right? So 0 is here, 50 is here. First of all, x is greater than 0. So x greater than 0 is all numbers on the right-hand side of this point. Next, you have x is less than 50. So less than 50 is here, right? And we need to find x that fulfills both of them. That's the common area of these two intervals. So that corresponds to the interval between 0 and 50. You see that? Okay, therefore, this is our final solution, which is x is greater than 0 and less than 50. Or if you want to write it in the interval notation, you can always say, you can also say x belongs to an interval that is from 0 to 50, exclusive on both sides. Okay, you can choose either method. All right, so that's the end of today's class. Do you have any questions to ask? If not, you are free to leave. Okay, very nice to meet you today, and I'll see you next lesson. Okay, have a nice day. Take care.